Hey y'all, welcome back to Math Rescue. This is part 2 on factoring quadratic trinomials. Last time we focused on the shortcut cases, where a equals 1. This time we're tackling the longer version, where a is not 1. These don't show up as often in your textbook, but they're super valuable practice. The algebra here really builds your precision and fluency for higher level math. We'll go step by step through the full process so you can factor any quadratic, even the tricky one. Let's get started. All right, so we have two questions here that we're going to work on together. Let's start with number 1. Now, I noticed for number 1 that my quadratic equation has not been zeroed out yet. I'm going to start with taking away 15 from both sides. So that allows me to write the quadratic in standard form. And from here, I'm good to go ahead and start my x games. So just like before with the shortcut version, we want to add to that middle term. So I'm going to go ahead and put my 7x there. That's our x term. But here's where it gets a little bit different. With the shortcut version, we actually have a leading coefficient of 1. When we don't have a leading coefficient of 1, that's when we have to do the full version of this factoring. So because we have a leading coefficient of 2, I'm going to go ahead and do a times c, which in our case is 2 times negative 15. And so that's going to give me a negative 30. So now I'm looking for two numbers that are going to add to 7 and multiply to negative 30. Two numbers that come to mind is 10 and negative 3. So 10 times negative 3 does give me negative 30. And 10 plus negative 3 does give me 7. So this is exactly what I wanted. Now, the whole point of this was so that we could take our trinomial and we could write our trinomial out as 4 terms. The reason we want to write it out as 4 terms is because we want to use factoring by grouping. And you can't really group 3 different things. So having it as 4 terms is going to help us factor by grouping. So let me go ahead and rewrite it. I'm going to split up this 7x. 7x is going to turn into 10x minus 3x. And then I'm going to go ahead and bring everything down around it. So let's start our factoring by grouping step. So I've created 2 groups here. I've created the blue group and the green group. And what I want to do now is I want to take the GCF out of each group. So from my blue group, I can see that they have a 2x in common. I'm going to go ahead and factor out 2x. And from my green group, I can see that they have a minus 3 in common. So I'll go ahead and I'll factor that out. When I factor 2x out of my blue group, it leaves behind an x plus 5. And when I factor out minus 3 from my green group, it leaves behind an x plus 5 as well. That's really important that what you end up getting in parentheses matches up. If they don't match up, that's kind of a sign that an error happened somewhere. Now at this point, I have 2 really big terms. Here's one of them, here's another. 1, 2, those are my 2 terms. Notice what the 2 terms have in common. They have the parentheses in common. Because they have the parentheses in common, I'm going to go ahead and factor out what they have in common. So I'll factor out that parentheses. Now, if I take the parentheses out of the first term, that leaves behind a 2x. And if I take it out of the second term, that leaves behind just the minus 3. All right, we are completely factored. We are good to go with our zero product property step. I like to call it ZPP for short. So we can go ahead and set each of these factors equal to 0. All right, and now we have these linear equations to solve. So one of our solutions is x equals negative 5, and our other solution is going to be x equals 3 halves. All right, let's get started on the next problem. So this one has already been zeroed out for us. So we can just go ahead and start with our x games. Our goal is to factor by grouping. So I'm going to want to split up that middle term. That's what we're going to want to add to. And since we can't do the shortcut version on this, I'm going to do a times c. That's 3 times 8 for this one. So we want something that multiplies to make 24. Now the first thing that comes to mind is maybe negative 12 and 2. So negative 12 plus 2 does make negative 10, but it doesn't multiply to make positive 24. So that's actually not what I want. I'm going to try something else. Let's try negative 4 and negative 6. So negative 4 plus negative 6 does make negative 10. And negative 4 times negative 6 does make positive 24. So this is exactly what I wanted. We're going to go ahead and use the negative 4 and the negative 6 to rewrite our quadratic, which is now a trinomial, into 4 separate terms. So it's going to be 3x squared minus 4x minus 6x plus 8 equals 0. All right, and then we're going to go ahead and do factoring by grouping again. So I'll go ahead and I'll kind of visualize my two groups with two different colors. From my first group, I can see that they have an x in common. When I factor out that x, that leaves me with a 3x minus 4. And from my second group, I can see that they have a negative 2 in common. And that leaves me with a 3x minus 4. Again, very important that your parentheses match up. If that does, that is a sign that you're on the right track. From here, I have two big terms. And I ask myself, what do those terms have in common? They have the parentheses in common. So we'll go ahead and we'll pull out the parentheses. Now, when I take the parentheses out of the first term, that just leaves behind an x. And when I take it out of the second term, that leaves behind a minus 2. And all of that is still equal to 0. From here, because we have something times something else making 0, I can use the zero product property to set each of these factors individually equal to 0. And now I can solve these much easier, much nicer linear equations. All right, I hope that helped. Good luck in your math classes.